So let's do a problem from the book, and I just realized that I've been referring to this section as 10.3, and I think I did that in a few of the videos, and in the homework I'll make sure that's clear. It's actually 10.2 as vectors. It's 10.2, not 10.3. Okay, so we're going to do section 10.2, page 546, number 40. So that's here, all right, and it says the velocity is given along with a position at time t equals 0. And find the position of the particle at time t equals 3 and the distance the particle travels from t equals 2 to t equals 3. So they give us a velocity function, and then here's what's interesting is they give us a point. Notice how it doesn't have angular brackets. It's a point in space. But really, it's a vector, all right, because it was a vector valued function. So if this function is derivative of the function that gave us this point, then this is really a vector. But you can see how calling it a point, it's a position, so calling it a position vector or a point is sort of interchangeable, whereas the velocity vector is more properly a vector. All right, but I would really make this a point. So a vector. So notice how they're giving us a velocity and a position at a particular time. In fact, at time t equals 0, so this is an initial position. So as usual with finding distance and displacement, if I want to find the position, I'm going to need to supply the information that was lost when we got the derivative. So that's why they give us an initial position. And then we're supposed to find the particle at the time t equals 3. Find the particle at the time t equals 3, the position of the particle. Okay, so we're going to find, I put displacement and distance over t equals 0, 3, but actually for part A, it says, so really part A says find the position at t equals 3, and part B says find distance over t from 0 to 3. So it's a little bit of a difference. All right, so let's do it. So we need to find so position is related to displacement. So that's why I said distance and displacement. So the first thing we need to do for part A is find the displacement. Since we're given the position at t equals 0, I guess I put that here. And I wrote it as a vector. So the position vector at time 0 is 1, 1. All right. So in order to find the position, we need to take the initial position and add the displacement to it, just like an accumulation problem, really. So the displacement is the integral from 0 to 3 of just the vector function v of t dt. All right, so that is equal to the integral from 0 to 3 of e to the t minus t, comma e to the t plus t dt, because this is our velocity function. All right, and so this time I'm not going to write separate integrals. I'm just going to say, okay, this is the vector that has the I'll just do my antiderivatives right away and then bring the limits in. So the antiderivative of e to the t is e to the t, and then t is t squared over 2, and we're going from 0 to 3. And then this one's going to be e to the t plus t squared over 2, also from 0 to 3. So I just brought the evaluation right in there. All right, and then so what is that? So when I plug in the 3, I'm going to get e to the 3 minus 9 halves. And then when I plug in the 0, I get 1, right? And then for my y coordinates, my y component, I'm going to get e to the 3rd power plus 9 over 2 minus, and that's then minus 1. Yeah. Okay. So then that is just e cubed minus 11 halves, comma e cubed plus 7 halves. So you could leave it like that, or you could, get a nice decimal if you like decimals, 14.586, comma 23.586. All right, that's the displacement. Okay, so that's how far the particle has moved, but it was at 1, 1 to start with. So the position s of 3 is going to be the initial position s of 0 plus the displacement. So that means we're going to go from 1, 1. So 1, 1 was like our starting point, and this is what direction distance we moved. So we're going to add that vector, 14.586, 23.586. So that means our new position is 15.586, comma 24.586. Right? So this is essentially like saying that we were initially at the point 1, 1. All right, and we moved 14.586 to the right and 23.586 up. So we moved a vector that goes 14.586 this way, and we went 24.586 this way. So this is our displacement vector. And this is the point where we ended up. So we started at the point 1, 1, and we end up at this point, 15.6. I'll round it a little more, 15.6, 24.6. So that's what happened. All right, so that is using displacement to find a new position. Next, it asks us to find the distance, so we will do that next.